Hello everyone, how are you? I hope that all of you are doing good. So here we are with the question discussion on AIT 5 JEE main paper of class 11th. In this question paper, we have selected some problems. I think that might be complicated for you. So we are here to resolve them one by one, and we will be discussing the concept behind them. Let's just get started with it. Now, the very first question on your screen is this. The volume V of water passing any point of a uniform tube during t second is related to the cross-section area A of the tube and velocity u of the water by. The relation is V directly proportional to A raised to the power alpha, B raised to the U raised to the power beta, time raised to the power gamma. Now, which of the following will be true? So it's a single correct option, only one option being true. Let's just start solving it. Now, the question is from dimensional analysis. So here we directly given a relation that V is directly proportional to A raised to the power alpha, U raised to the power beta, and time raised to the power gamma. Now, what we'll be doing, we will assume that something constant will equate this equation as A raised to the power alpha, U raised to the power beta, and time raised to the power gamma. Now, we will be analyzing the dimension on both the sides. So we know that the dimension formula of volume is M0, L3, T0. Now K is constant, so there will be no dimension to this constant. Now here, the dimension of A is nothing but area, which is L square raised to the power alpha. U is velocity, which is nothing but LT minus 1 raised to the power beta. And here time itself is T raised to the power gamma. Now we have to equate the powers of L and T on both sides. So here we only have L3 and T0 is equals to, here we have, this will become L raised to the power 2 alpha. This will become L raised to the power beta, T raised to the power minus beta, and T raised to the power gamma. So base are same, power will be added. L raised to the power 2 alpha plus beta, time raised to the power minus beta plus gamma. Now if we compare here, time is 0, time raised to the power 0, and here time raised to the power minus beta plus gamma. So minus beta plus gamma should be 0. If base are same, power will be equated. So here gamma is equals to beta. This is the first relation. And second relation is that L raised to the power 3 is equals to L raised to the power 2 alpha plus beta, which means we can say 2 alpha plus beta is equals to 3. By anyhow, 2 alpha is equals to 3 minus beta, and alpha is equals to 3 minus beta upon 2. So from here we can say alpha is not at all equals to beta and not at all equals to gamma, which means this is coming out as alpha is not equals to gamma, beta and gamma, but beta and gamma itself are equal. So option B is the correct one. Now I hope you understand this. Move on to the next one. This. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approaches this car in the opposite directions with a speed of 54 km per hour. At a certain instant, when the distance AB is equals to 1 kilometer and it's also equals to AC, then B decided to overtake A before C does. What minimum acceleration of car B is required to avoid the accident? So it's a very important job here. So let's say we have a lane here. These are the two lanes. Okay, this is a kind of road we are having. So here we have this vehicle. Let's say this is A. and on the opposite side, the another vehicle is approaching this. Let's say this is C, and from this side, vehicle C, vehicle B is approaching. So according to the language of the question, car A is traveling with 36 km per hour. So VA we can say 36 km per hour. Now it's very important here to convert this kilometer per hour into meter per second because answer is mentioned in the meter per second. So to convert VA into meter per second, you have to multiply this equation by 5 by 80. So you need to remember it. If you want to convert kilometer per hour into meter per second, you need to multiply 5 by 80. If you do want to do opposite of it, like you want to convert meter per second to kilometer per hour, then you have to multiply with the inverse of 5 by 18, which is 18 by 5. So 5 by 18 into 36 will become 10 meter per second. Similarly, VB will also become what? 5 by 18 into 54, which is nothing but 15 meter per second. Now, same goes for VC because VB and VC are same. Okay. Now, if you will see here at an instant of time, the distance between AB is 1 kilometer and distance between VC is 1 kilometer. 1 kilometer. Okay. Now it's very obvious that if we observe the motion of both the cars from the point of view of A, we will be finding that this C is moving faster than B because it's in the opposite direction. Okay. So if you calculate velocity of AC, which means velocity of CA, which means velocity of C with respect to A, and both are in opposite directions, so they will add up 10 plus 25, which is equals to, 10 plus 15, which is equals to 25 meter per second. Now, this car will take how much time to cover 1 kilometer? So for that, x is equals to, t is equals to what? X upon v. X here is 1000 meter. V is what? V is 25. So according to the situation, V is taking 40 seconds. C is taking 40 seconds to cover up this 1 kilometer. Meanwhile, B will take greater time than this. But the question says that B has decided to cross A before C does, which means at least B should be moving, should be covering this distance of 1 kilometer at least in 40 seconds. Then there's a point we can avoid the accident, which is the minimum value of time, okay, that it will consume. Okay. Now, if we taken up this time here to calculate the acceleration of this car, which is B, so for that we should be knowing what is VBA. VBA is nothing but VB minus VA, and both are moving in the same direction, so velocity would be 5 meter per second. Okay. So for using this velocity, what should be the acceleration of the car so that it would cover, and that acceleration must be constantly applied to this. Okay. Ut plus 1 by 2 at square. Now we know that time you have to consume is 40 seconds. Okay. S is given to you as what? S here will become 1000 kilometer. U is nothing but VBA you will be using here, which is 5 meter per second into time is 40 plus 1 by 2 acceleration that we interested in to calculate, and t square is nothing but 40 square. So this will become 200. 1000 minus 200 is 800. And similarly, this side also you will be finding it is coming out as 800. And this is 8. So acceleration of the car is 1 meter per second square. That is the minimum value, which means at least you require 1 meter per second square of acceleration. So the car B will overtake car A and also avoid the accident. Got it? If you take up acceleration is 2 meter per second square, ultimately you will decrease the value of time. You will be taking time as 35, you can take as 30 second, whatever the time. But this is the maximum value of time so that you are getting the minimum value of acceleration. Okay. Now, this one. A projectile is given an initial velocity of I cap plus 2j cap meter per second square. So here the velocity vector is I cap plus 2j cap, where I is along the ground, which is the horizontal component, and j is along the vertical, which is the vertical component, basically. G is given you as 10 meter per second square, the equation of its trajectory. So always remember to find out the equation of trajectory in any kind of motion. And here is a projectile motion. So definitely the projectile will be, the trajectory will be parabolic. So for that, you consider the particle at any general point xy at time t. So for that, we need to find out the relation between x and y. And how do we do that? Because the velocity is given to us, so we can say that Vx is nothing but 1, which is a component here, 1. And similarly, we can say that, and this is Ux, initial component, initial x component, and this is Uy, which is the initial y component. Now at this time t, the horizontal distance covered is x only, and the vertical displacement is y. Since the acceleration of gravity is constant here, so we can apply the equation of uniformly accelerated motion. Sx is equals to uxt plus 1 by 2 times axt square. Now Sx is nothing but x is equals to ux will be 1 into t, and since we do not have any acceleration in horizontal direction, so ax will be 0. So this whole term will become 0. X will become here as t. Okay. Now it's done for y. So Sy is equals to uyt plus 1 by 2 times ayt square. Now Sy is y, uy is 2, according to this, time is t, minus 1 by 2 times gt square. Why minus? Because gravity is acting in downward direction. And the velocity that we have taken upward is positive, and downward side we have taken as negative. So y here will become, put the value of t in terms of x, 2x minus 1 by 2 times g is 10 t square. Y is equals to 2x minus 5. In place of t, you put x, so it will become 5x square. This is the equation of trajectory. And according to the option B is the correct one. Now, next one, a 1 Newton pendulum bob, 1 Newton pendulum bob, which means the weight force is given. You don't need to calculate it separately. 1 Newton pendulum bob is held at an angle theta from the vertical by a 2 Newton horizontal force F as shown in the figure. And the tension in the string supporting the pendulum bob in Newton is. So we can be applying two approaches here, but solving it for one approach here. Let's say the tension in the string is T. So what we will be doing, we will be resolving these two components into horizontal and vertical direction. And then finally equate them. So pendulum is all 1 Newton pendulum, which means in downward direction it is applying 1 Newton of force. Now, if this angle is theta, this angle is also theta. So if you resolve tension, it will be T cos theta in this way and T sin theta in this way. Okay. Now, if this pendulum is held here, which means it's not moving, so we can say that net force is equals to 0. And sigma net matlab sigma fx plus sigma fy. Sigma fx is 0 and sigma fy is 0. Now in fx direction, we have force is equals to F is equals to T sine theta. There is nothing other forces are acting here. So F is equals to T sine theta. Now T cos theta equals to 1. This is equation number 2. Now this horizontal force F has itself a value of 2. So we can say that T sine theta is equals to 2 and T cos theta is equals to 1. Now whenever you find this sine theta and cos theta, always try to use the square method. Take up the square of equation 1 and 2 and add them. So you will finding out it will be T sine theta whole square plus T cos theta whole square. And on the right hand side, we will be finding 4 plus 1. This will become T square into sine square theta plus cos square theta. Try to make it identity. It is 5. So sine square theta plus cos square theta is 1. So tension here you will get as root 5. Option C is the correct answer. Now move on to the next one. Yes. It's a very interesting question. Consider a system of block X, A and B as shown in figure. The block A and B have equal mass and are connected by a massless string through a massless pulley. The coefficient of friction between block A and X or B and X is 0.5, which means between A and X and between B and X, the coefficient of friction is 0.5. If block X moves in the horizontal frictionless surface, what should be its minimum acceleration such that block A and B remain stationary? So it's all about to maintain the stationary state or rest state of block B and block A. Now, if in general, if I try to draw the FBD of block B, there is a weight force of this B is acting downward. And similarly, the tension will be developed in this pulley and string system. Now, if this block try to move in downward direction, the frictional force will be acting in the upward direction. And one more factor here, when this block will accelerate because it is moving, what should be the minimum acceleration such that block A and B remain stationary? So if this block is moving with respect to these blocks, this block A and block B is also moving with respect to the ground, which means, and this is moving with some acceleration. So these two particles or these two blocks A and B is in a non-inertial frame of reference in which we cannot apply Newton's law. So for that, we have to consider the concept of pseudo force here. So for that, we will be sitting on this and observing the motion of A and B. Now, if B is moving downward, A will try to move in this way. So oppositely, there is a value of friction will act. Now, if let's say this block X is moving in the forward direction, A. So now the FBD of block B will be like this. This is block B. There is a force mg in the downward direction, upward force tension, and upward force friction. Okay. Although friction will depends on which value of the force is greater. So I'm assuming that mg is greater. So F will try to oppose it. Now this block X is moving in the forward direction. So there is a pseudo force which will be acting on this block B in the opposite direction of the movement of X. And that is nothing but mass of this block B and acceleration of the system. Now, on opposite to that, the normal reaction will be developed. So we can say here that N is equals to ME. This is equation 1. Now, if this block is not moving, we have to equate these forces. T plus F is equals to mg. Okay. Now, T plus, for not moving this block, this friction should be static friction, which is nothing but mu into m into g. This is equation 2. Now let's just draw the FBD of block A. This is block A. There is a tension force in this direction, frictional force in this direction, normal force in the upward direction, and gravitational force in the downward direction. Now one more force over here is the pseudo force, which is opposite in the direction of motion. I mean, so we can say that T is equals to MA plus F, and for there F is equals to mu n and n is equals to mg for this one. So it will be mu m into g. Now we got two equation of tension. Let's say this is not equation 2. This is equation 2. Mg minus mu m a. We have put down the value of n over here. This is equation 2. Now if you equate equation 1 and 2, you will be having me plus mu mg is equals to mg minus mu m a. Okay. Now you will take this mu m at this side and ma at this side, because we want to know the value of a only. So here we will be putting down the value. You can get the m cancel out from each side. So it will be a plus mu g plus g minus mu a. Mu we have as 0.5, so it is 0.5. If you grab this on this side, it will become 1.5. And if you take up this on the negative side, this is 0.5 g, so it will become 0.5 g only. A will become g by. So this is the minimum acceleration that is required for not for the stationary condition of an. Now let's just move to the next question. A body of mass m is taken up by an agent on smooth inclined plane of inclination theta, where sine theta is equals to 1 by x, with constant acceleration a meter per second square. The final velocity of the body is v meter per second. The work done by the agent during this motion is initial velocity of the body is 0. So initial velocity of the body is 0, final velocity of the body is v. So we can say by work energy theorem, the work done, net work done, or the work done by all the forces is equals to change in kinetic energy. Now, work done net is equals to 1 by 2 times mv square only, because initial kinetic energy is 0. So this is equation 1. Now let's just imagine the situation. This is a kind of wedge on which this mass m is moving from here to. Now let's say this mass is moved by this distance. Let's say this is s. This angle is theta. Now here we have two forces. One is the agent force that we have applied, the agent, and second force is gravitational force. Both are doing work. So this work done net here is nothing but work done by force plus work done by gravitational force is equals to 1 by 2 times mv square. Now we can find out this work done by mg. So for that, we need to resolve the mg in the direction of displacement, or you can resolve the displacement in the direction of mg. So which one is easier? Let's say this is, for that you need to mention is at h. So work done by mg force here is mg dot h, and since both are in opposite direction, h we have covered in the upward direction, mg is acting in downward direction, so it is coming out as minus mgh. Now we do not know anything about h, so what we can say, h is nothing but the vertical component of this s, so we can say minus mg s sine theta. It's very simple to say. Now work done by mg force is equals to minus mg s. Now what is the value of sine theta? Sine theta is 1 by x. 1 by x only. Okay. So for that, this is the work done by mg force. This is simply the work done by mg force. Now what we can do, we can put this work here. Work done by the agent minus mg s into 1 upon x is equals to 1 by 2 times mv square. Since the acceleration of the body is also given to you as constant acceleration is a. So what we can say that this distance covered by this block, we can say that v square is equals to u square minus 2as plus 2as. Since the initial velocity is 0, so we can say that v square upon 2a is the value of s only. Now the work done by this agent is nothing but half mv square plus mg. If you put the value of s, it will be v square upon 2a into 1 by x. Now you can take the commons. So work done by f is equals to, you can take 1 by 2 times a and mv square as common. So it will become, and you can take x also as common. So it will become, the half mv square has gone, half mv square has gone. Okay. The only thing remaining is ax or xa. If you multiply that, it will become 1 by 2 mv square. Because xa is not present in the first expression, so we have divided it here, so we have to multiply it here. Plus, we have taken m v square 2ax as common, only g is remaining, so you mention g. So this is the work done by this agent, and it is given by mv square upon 2ax exceed g plus x. Option D is the correct one. Now move on to the next. Yeah. A boat of mass 1000 kilogram goes from rest to speed 20 meter per second in 5 seconds. The water exerts a constant drag force and the acceleration of the boat is constant. If the average power required by the boat is 45,000 watt, then the magnitude of drag force is. So here average power is mentioned as 45,000 watt. Rest to speed this, so acceleration we can calculate here is v final minus v initial divided by time taken, which is 20 upon 5. It's 4 meter per second square and it is constant. Why? Because the force exerted is constant. The acceleration of the body is constant. So this is a constant value. Now, if we apply work energy theorem here, the work done net is equals to change in kinetic energy. Okay. Now, The net work done here is given by work done by drag force plus work done by the boat, the engine, plus 1 by 2 times of mv square. Now, we know the acceleration of the boat is 4 meter per second square. Okay. Now, from here, if you will calculate that how much the boat has displaced in 5 seconds, it's easy. S is equals to 1 by 2 times at square because u is 0. So it's only 1 by 2 at square. So S will become here 1 by 2 times. A is what? A is 4 meter per second square. And time is 5, which is 25. So value of S is coming out as 50 meter. And this 50 meter is displaced because of the engine work. Because drag force is opposing this work. So work done by the engine force is nothing but force into displacement. Okay. Force is given by mass into acceleration and displacement is 50. Mass is 1000 divided by acceleration is what? 4 into 50. So it will become 4 5s are 20, which is 1000 multiplied by 200. So this much is the work done in joule by this is 200 multiplied by 1000. Now, if you calculate the work done by this is the final expression 1 by 2 times 1000 into V square is what? V square we are having as final velocity is 20 meter, which means 20 into 20. Again, if you are seeing here that it is coming out as 200 into 1000. Okay. So this, what we have calculated is the net force, net work done. Okay. Clear? Now, we know that the average power is consumed in this expression is 45,000 watt. This average power contains for what? This average power contains the power that we have lost doing work against the drag force and to pull the boat 50 meter away from the starting point. So power is nothing but power क्या होता है? Power is nothing but net work done upon delta T. Clear? The net work done here is coming out as 200 into 1000. Then you need to multiply power into delta T. Power is already given to you as 45,000. And you have already calculated the work done by engine force. By doing so, you can calculate the work done by drag force. Okay. Clear? I hope that you have understood this concept. So, as I'm talking about, power is nothing but the work done. This power is consumed by the engine only. So we can say that this power here, let's say power, is nothing but work done, force of boat multiplied by the displacement divided by delta T. So from here, if you will see, this is 45,000. Force of boat, we do not know the value. Displacement, we know that the displacement is 50 meter divided by delta T is 5 seconds. Now this cancel out one of the 0, 5 and 5 will cancel out. So from here we know that boat force on the boat is 4500 Newton. Got it? But we know that net force, which is actually accelerating this boat, is equals to force of the boat minus drag force because drag force is acting opposite to this. So F drag here is equals to F of boat minus F net, and F net is nothing but mass into acceleration. This F boat we have already calculated. Now F net is mass 1000 into acceleration is 4. So around 500 Newton, the drag force is applied. Now in these types of question, always remember whenever the power is mentioned, this power is mentioned for the boat force only. This power is mentioned for the boat force. Okay. The acceleration in these types of question is the net acceleration. If two forces are acting, like in this question, drag force and boat force are acting, so the acceleration is produced by net force, which is the difference of these two forces or the summation of them. Okay. Now this one. By looking at this question, it seems like a very tough question is written in front of us, but it's very easy if you know how to utilize it, how to utilize the formulas or concept that we have learned. Now, what with what minimum speed v must a small ball speed v must a small ball should be pushed inside a smooth vertical tube from a height h so that it may reach the top of the tube. The radius of the tube is r, and radius of assuming radius of cross section of tube is negligible in comparison to radius. Okay. So what the concept here is, if you will see, this ball will move like this, but this is a solid, it's a tube. So this surface is also solid. So what we can say, when ball reaches at the top, similarly, if this ball is tied to a string and we push it in this direction. So at the vertical movement, when it is reaches at the maximum point, tension should be zero. Tension to zero हो ही जाएगी. But the condition is that velocity will not be zero. So we should have some minimum velocity here so that it will, due to the inertia, it will crosses this position and ultimately then tension will come out. So it will complete the circle. But in this hollow tube, we doesn't require any tension because as the ball will move here also, it will provide some normal force to this. So ball will never reach to this, never go down like this. So here we can say that if we push the ball just by this amount, here the velocity can be zero because tension is already present. So don't worry about it. So what we can say here that 1 by 2, we can say that the kinetic energy initial, potential energy initial is kinetic energy final, potential energy final. Initial kinetic energies, we have pushed it with V. So 1 by 2 times mv square. Initial potential energy, let's say this is the reference level and from this reference level the height is h. So it is mgh. Final kinetic energy is 0 because we do not require any velocity at the top of the, we just want to push it at the top point. By reaching at the top point, the velocity can be 0. Don't worry, because the ball is not going to come in the downward direction because this it has a support here. That can be 0. Final potential energy is this. This distance is nothing but 2r. And here that is why this the thickness of the tube is negligible, we have assumed, so that we directly measure it as 2r. Okay. So everything is given in the question has some point. Not every time, but sometime. Most of the time. So here you will see we need to find out the velocity. So it will become 2 mgr minus mgh. So m and m will cancel out from both the sides. So we have v square is equals to 4gr minus 2gh. V is nothing but square root of 2g, you can take common. So it will become 2gr minus, sorry, 2r minus h square root. Option D is the correct one. Now move on to the next. This one. A bead can slide on a smooth straight wire and a block of mass m is attached to the bead by a light string of length capital L. The block is held in contact with the wire with the string taut and is then let fall. The bead has mass 2m. When the string makes an angle theta with the wire, the bead will have slipped at a distance. So what is the situation here? This is a bead which can slide over this string. Another string is connected with the bead to this block. Now in this situation, we have stretched out it, which means this is taut, which means there is some tension in the string right now. When we let this block fall, so this block will fall in downward direction. Ultimately, this bead will move in this direction. It's very simple because tension will attract, tension will apply a force on this block. So what is the displacement of bead when this block has fall at a certain angle theta? This is the question. Now let's say we know that the concept that we are going to use in this question is concept of center of mass. Initially, there is no force acting on the system externally. So whatever the position of center of mass we have initially, same will be remain after the process because there is no external force on the system. External force on the system is zero. So here we can say this bead, let's say at an angle theta, let me draw it here, from the initial position. Let's just calculate the initial position center of mass. So x center of mass is nothing but, if we assume the origin at this bead only, so we can say 2m into 0 plus m into capital L divided by 2m plus m, which is L upon 3, equation 1. Now let's just say the bead has moved from its initial position to this position when the block has displaced at an angle theta. Okay, the bead has moved, let's say, a distance x in this horizontal way, while this distance is L and block we have here. Okay. Now, final center of mass will, this is the initial position. So from this origin, this mass 2m has shifted at a distance x. So we can say that this is 2m into x plus this block has shifted from this position. So initially we can say it is at this position. It has also some shift here. And this distance is nothing but from the origin. It will be x plus this amount. And this is nothing but the horizontal component of the cell, which is x plus, or we can say m into x plus L cos of theta divided by 2m plus m. Now we know that there is no shift in the original position of center of mass. So x center of mass initial is equals to x center of mass final. Okay, clear? So it is L by 3 equals to 2mx plus mx plus L M L cos of theta divided by 3m. Now, from the above equation, we can cancel out m. So it will become L by 3. 2x plus x is 3x plus L cos theta by 3. This 3 and 3 will also cancel out. So from here we can see it will become L into 1 minus cos of theta by 3. This is the value of x. So option C is the correct. Now this one. A thin wire of length L and mass m is bent into the form of semicircle. Its moment of inertia about an axis joining its free end. Joining its free end means this axis is nothing but the diametral axis. This is the diameter of this ring, semicircular. So to solve this kind of question, what we will do, we will assume a part of this ring of m, mass m. Got it? So what would be the total mass now? It will be 2m. So moment of inertia about diametral axis of a ring is given by 1 by 2 times m. Now m here will become 2 times of m into small r square. Got it? So we have removed the half of the part. So ID final is nothing but I diametral by 2. So it is, if we take it here, like this will be 1 by 2 times of m r square. Now r is nothing but the length of the wire is given to you as L. So length is nothing but pi r. Pi r is equals to L. The value of r is nothing but L upon pi, because all the answer is mentioned in terms of L. So that's why we are doing it. R is nothing but L square upon pi square. So it is ml square upon 2 pi square. So option C is the correct one. Now this, in going from one city to another, a car travels 75 km north, 60 km northwest, and 20 km east. The magnitude of displacement between the two cities is. So let me draw first of all the directions. So to solve this question, we need directions. This is, let's say, east, this is west, north, and south. So the car, let's say, start from its journey from this point on, and this is the situation of, or the point represent here the city 1. Okay, it is moving towards north. First of all, 75 km north, let's say here 75 km. Then it move in northward direction, which means at 45°, 60 km of amplitude, and after that it's move in the direction of east here 20 km. So this is the position B, let's say position B of city B. So actual displacement is this from A to B. Let me use another color. So this is the displacement line. Okay, we need to find out this vector. So what we can do here, we can use a vector analysis. We will write the displacement vector, let's say delta S is equals to delta x I cap plus delta y g cap. Now delta x I cap is nothing but the displacement on x-axis, which is only 20 j cap. If you will see, it's 20 j cap. What we are going to do, we have three distances covered: 75 km, 60 km, and 20 km. Got it? So if you want to write x component of the displacement vector. All the x component you will be adding here, which is 60 kilometer x component, this one. So it will be as 60 kilometer because it in the positive, it is in the negative direction. If you will see this one, 60 kilometer northwest. So it is minus 60 cos 45 I cap plus 20 cap, 20 kilometer we have covered in positive, which means east direction. So it is 20 I cap. Now here delta xy, or we can say it's delta x only. Delta y will become what? 75 kilometer, which is 75 G cap plus 60 sine 45 G cap. This is the component in this direction, this one. So it has, this vector has two components. This is the vertical one, this is the horizontal. Now delta s vector is nothing but delta x I cap, delta y G cap. So we will mention all the values. Cos 45 is 1 by root 2 I cap plus 20 I cap plus 60 by root 2 J cap plus 75 J cap. Now this 1 by root 2 is nothing but 0.7. So we can mention it 60 upon 0.7. 60 into 0.7 I cap plus 20 I cap plus 60 into 0.7 G cap plus 75 G cap. Now this will become 642 minus 42 I cap plus 20 I cap. This will also become 42 G cap plus 75 G cap. Okay. Now from here onwards, if you will see, this minus 42 I cap plus 20 J cap will become minus 22 I cap plus this will become 5 plus 2 is 7, 4 plus 7 is 11 J cap. Okay. So if you take the displacement vector, it will be square root of 22 square plus 117 whole square. It ultimately gives you 119 kilometer. Now this one, two satellite 1 and satellite 2 are moving around a planet. Here we have a planet P, and these are two satellite moving in path 1 and path 2 of radius r and 3r. With a speed, satellite 1 has a speed v, this is v, and satellite B has a speed kv. Find where is k is irrational number, find the value of 1 by k square. So we know that in the orbit they are moving with the orbital velocity. So v orbital is nothing but 1 square root of gma upon small r. So we know that VO1 by VO2, we can say it is nothing but R1, R2 upon R1 because it's inversely proportional to the radius of the orbit. So VO1 is nothing but V, VO2 we need to find out, and which is ultimately given as kV. So you can put that also. And here R2 is 3V, 3R, and R1 is, and that is capital R, doesn't matter, and it is capital R. This will cancel out, V and V will cancel out. So 1 by K here is root 3. If we take the square of it, 1 by K square will become 3. The value of K square is 1 by K square is 3. Now this one, a rubber cube of 5 centimeter has one face fixed while a tangential force of 1800 Newton is applied on it. Opposite face. If modulus of rigidity is this, then the lateral displacement of the strained face is. What is the lateral displacement? First of all, you need to understand this is the block. We have applied a tangential force over it. So it got disturbance in shape like this. This value of x is nothing but the lateral displacement, which is nothing but the ratio of x by L for small displacement. So we can apply Hooke's law here. The area of cross section is nothing but 5 into 5, which is 25 into 10 raised to the power minus 4 meter square, because it is given in centimeter. Force is 1800 Newton. So we can say that tau here, which is the shear stress is only going to develop this kind of strain in it, which is force tangential upon area, 1800 upon 25 into 10 raised to the power minus 4. According to Hooke's law, we can say tau is equals to z phi. So tau is given as 1800 25 into 10 raised to the power minus 4. G is given as 2.4 10 raised to the power 6 into 5. Now do some cancellation. This minus 4 will go here, so it will reduces the power to only 2. This will vanish out from here, and the power will be only 2. This 2 power will cancel out the power here. So we have phi is equals to 18 upon 25 into 2.4. 110 you can multiply to remove this decimal, so it will become 24. 6 3 is 18, 6 4 is 24, 5 5 is 25, 5 2 is 10. So phi here will become 6 upon 20. Now phi is nothing but x upon L. L is nothing but 5 into 10 raised to the power minus 2 meter. When you multiply it, it will become 5 4 2 3. X will become 1.5 10 raised to the power minus 2 meter. We can say it 115 into 10 raised to the power minus 3. There is no problem in that. So it will become 15 mm, because 1 into 10 raised to the power minus 3 meter is 1 mm. Option C is the correct. So I hope you have got this. If you have any kind of doubt other than these questions, you can connect to me over the regular classes. Hope you would enjoy this session. Thank you so much. Bye bye. Take care.